So our final keynote for the day is by Ashmita Kapoor, who is going to walk us through how to build a scalable Web3 infra with GCP. Ashmita Kapoor is an app modernization specialist for Google Cloud, helping SEA customers to realize and fast-track their digital transformation journey. Talking about Kubernetes and containers is her passion, and she comes with an experience of working with multiple customers on serverless PaaS and FaaS technologies. Hi Ashmita, we warmly welcome you to our AI forum. Over to you.
Hey, thank you so much for the introduction and good afternoon, everyone. I'm here to talk about how Google Cloud is helping in this entire Web3 area. Right? In cryptocurrency, when I talk about Bitcoin, it just took the world by a storm. And after that, there has been so many more who have joined this club. Ethereum, the Elon Musk famous Dogecoin, Tether, there is just no end to the number of cryptocurrencies available today. Then there are NFTs, DAOs, DeFi. But do you know where it all started and how all of this has come together? What really happens in the back end? I am sure you have heard of Web3, but is that another word in the mix, or are all of these related? In the next 40 minutes, we will take a journey on how all of this has evolved and how we at Google Cloud are helping Web3 organizations solve the many challenges that there are. Do you remember how the web was for us initially? It was like a huge Wikipedia with information available for us to consume. Decentralized, open, and as anyone could build on it freely, but mostly it was read-only, as only few folks had the skills to publish content. This is what we termed as Web 1.0. There were web pages which were created, a way for users to navigate across the internet. Then came in the era of Web 2.0. That is where we are right now, the world of the social media. Web 2.0 became a two-way street. Content was available for us to consume, but in return, we provided our data as well. Now, this data was used to personalize what is being shown to us. Like, for example, my Facebook feed would be very different than what you see. The promotions and the ads that are given to me will depend on what I have been surfing on the internet. Web 2.0 was a world which was based on monetizing on personal data. The openness was lost, and the privacy had become a question. This is an internet era which has been dominated by companies that provide services in exchange for the data that we provide. But we did sign up for this. We did sign up to share our data to them. But that is not what the problem was. The problem was that who got control of this data and how they were using it. With Web 3.0, we aim to solve just that. Going back to the world of decentralized and removing the need of middlemen. Web 3 is about giving back the power to the hands of users. The users here has direct control of the digital entities and data. Anyone is allowed to participate without having to give up their data for monetization. Now think about all of the various industries that Web3 can make a difference. Now, when I want to send money to someone or receive, there will be no more need of an intermediary or a middleman. Say when I'm trying to claim an insurance, it will be all driven by machine and nobody having to come in and say, okay, why you should get that claim reimbursed or not. You get supply chain traceability. Or even very simply, when you want to rent or buy a house, imagine all of the hidden costs and hurdles that you have to go through just to get one. Web3 will aim to remove all of that and make the world a lot more open and work towards our privacy. This technology is quickly living up to its name. There are about 80 Web3 unicorns today, and $930 billion in the total crypto market cap. 30 million MetaMask monthly active users, and there has been a 65% Web3 developer growth. Approximately 4.2% of the global population is owning crypto assets today. I hope you are too, at least I am. Now, at a high level, Web3 is composed of unique use cases like NFTs, which are non-fungible tokens. These are digital assets that you can own a part of the internet. Then there is DeFi, decentralized finance, a blockchain-based form of finance that does not rely on any intermediary, like banks, brokerages, exchanges. Then there are cryptocurrencies, the most famous Web3 use case that there is. These are decentralized digital money. Then there were created DAOs. These are distributed autonomous organizations, a group organized around a mission that coordinates through a set of rules enforced on a blockchain smart contract. All of these use cases are enabled with the use of blockchain and smart contracts. Now let's try and understand what a blockchain is and how it works. Now, when I talk about a blockchain technology, it's basically a protocol that allows to store data across a network of nodes. In a peer-to-peer network, you can store these data, execute transactions. It's like a distributed database, a distributed ledger. It enables us to secure way to record and keep track of the info without having to have a central ecosystem. Now let's just quickly understand how this works. Now say A wants to send 5 Bitcoins to B. A's wallet will produce a digital signature for the transaction which is based on A's private key. Now this will prove that A does have 5 Bitcoins to send to B. Now this transaction is represented as a block. If you see the way the block has been designed, it makes it immutable. There are 3 basic areas in a block. You have the data, that is say 5 Bitcoins are being sent from A to B, and the digital signature. The hash of the block which defines, okay, this data along with the hash of a previous block is the signature for this particular block. Now you would say, why do you need a hash of a previous block? Whereas the name suggests, blockchain is a chain of blocks, right? So that particular block, this new transaction which has come in, needs to add into the chain of blocks. So therefore it needs the previous hash as well. Now the moment you change any of these two, whether the data or say the hash of the previous block is tampered, no more it's the same block, because a block is immutable in nature. This is the way that it ensures that security is maintained. Now, this particular block which has come in as a new transaction is then broadcasted to every node in the P2P network. Now, to be able to process this transaction, all nodes need to come to a consensus. Now, there are 2 popular methods to this. You have the proof of work or the proof of stake. Once the node reaches the consensus, the block is then added to the chain and B gets the money. If you do not know what proof of work or proof of stake is, just go and read about it. And there's one particular thing for you to notice. Try and see which is more sustainable in the environment today. Bitcoin uses proof of work for a consensus algorithm, whereas Ethereum is moving towards the proof of stake. Now, this entire way of working makes it irreversible, composable, completely auditable, and in a completely decentralized distributed ledger. Next comes our smart contracts. Now, a smart contract in a developer lingo is called if then else, right? All of the developers who are today have definitely coded that. Now, these are self-executing terms of agreement directly written into code, which is deployed on the blockchain network. And they're executed when the conditions are met. Let's take a simple example to understand what smart contracts are. We've all used vending machines, whereas you've given a money, the machine itself checks whether the money that you've put in and the snack that you've selected is can be given to you for the money that you've given, right? So if the amount of money applies to the snack that you've given, then it will give you the money, else it will not. So this is a kind of a smart contract that there is, which has no middleman in between. Now, who can write a smart contract? Well, anyone can, until with two particular things. One, you need Ethereum, because you need Ethereum to deploy these smart contracts, and you need to know the smart contract language. Next is the DApp, or the decentralized applications. Now, once I've understood what a blockchain is and smart contracts, I'm sure you want to start trading now, right? Will you start coding to do that? Now, I'm like a lot of you here, you might not be a very code friendly person. So a decentralized app basically helps you with that. Just like any traditional application that you see today, a decentralized application is a front end, right? Just like a traditional app, but it uses the backend code as the form of a smart contract. The difference between a DApp and the regular traditional app is that it is non-custodial. It is not owned by a single organization. What you see here are many examples of dApps that exist today. Uniswap is one famous which uses to swap tokens. OpenSea helps you to acquire NFTs, as I said, a part of the internet. Now let's see how all of this comes together. All of this together makes a Web3 construct, a Web3 architecture. I've of course not spoken about all single items here, but only touched an upper layer. Now, as you've heard me, I'm sure there are a lot of questions that come in mind. There are a lot of challenges that you would have thought of immediately when you talk about Web3. Now, let's look at few common challenges that there are. Number one, network. Now, since we said that they can be anywhere and they are not owned by one organization, there is a need to have a fast and a reliable global network so that the nodes can interact with each other. And say if I'm an NFT organization, I need to reach to my gamers, right? And they can be wherever they are. And I need to reach to them and them to access my app, the dApps that there are, in a very, very low latency. Second is security. As everything is anonymized, and again, there is no central ecosystem, security becomes a key. Being a distributed ledger, the data needs to be stored or in transit when they are being processed. They need to stay encrypted and private at all times. The third is developer experience. Now, Web3 is a growing market, right? There's innovation that is needed. So more than ever, the developers need to be able to have the flexibility that they are able to innovate. So you need a platform, you need a platform as such that is able to maintain you to release fast without having to worry about infra maintaining or security, right? Just because I'm releasing fast, I don't want to sacrifice on security, but I would rather want to shift left. Then comes data. There's huge amounts of data that being processed. So you need to, at any given point, need to know in a real-time manner, look at, say, an historical chain analysis, a smart contract insights, transaction details that are happening, or detect fraud very quickly. And the last and for all is where you're deploying all of this. Where are your nodes? Where are your applications being deployed? Infrastructure is a key. And scalability is now important more than ever. And you need to scale on demand to be able to match unpredictable volumes rather in compared to the other traditional apps that we have. Now let's see how we at Google Cloud are helping you solve each one of them. And we'll also take a look at how we've helped different companies achieve all of these 10x visions. Now, the reason that people choose Google Cloud in this era is because we are able to provide you a massive, scalable, and a secured infrastructure with low latency across the globe. Now let's look at each challenge and what the solutions are. First, infrastructure. Now many Web3 applications and node infrastructure today are running is something very common and you all have heard of containers. And they run on GKE because that's the best place. They run these nodes and applications on GKE as containers, and you would ask, why containers? Because we could have run it on a compute engine itself, right? on just another VM. I don't need to containerize my applications and run it. Well, yes, you can still run it on a VMs because Google Compute Engine does provide you the ability to scale on demand. So you will be able to meet the unpredictability demand that you get. And the nodes are all either CPU intensified or memory intensive ones. So you can choose what suits you. But the reason I talk about containers is because it assures you, along with GKE, that the containers are immutable, they are portable, and they are able to individually scale horizontally and vertically, right? GKE gives us the ability to be able to scale your app as well as your node, not only horizontally, but you are able to scale vertically as well. With GKE Autopilot, we take it one level up. We tell you that you don't even have to manage your nodes anymore because Google becomes your SRE. We at Google manage your master nodes as well as your worker nodes, therefore be able to give you 99.95% SLA of uptime. And availability is again a key in the blockchain world. We are able to help you reduce node provisioning time or having to maintain the nodes and the application time. Customers have tested GKE at a record-breaking 15,000 nodes for a single cluster. And we are 3.2 times faster when it compares to competition. But then you would ask me, GKE is only available on GCP. What if I have a regulation and I cannot go on the cloud? I need certain aspects to run on-prem. So in this scenario, if you have a need for adopting a multi-cloud or a hybrid strategy, Anthos gives you the capability to take the same GKE on-prem or on other clouds. Now, the reason why Anthos is popular in this area is not just being able to give you Kubernetes engine, but it also helps you able to manage all of these clusters wherever they are deployed from a single control plane. You are also able to do security governance, infra and service management across multi and hybrid cloud. Now, this is about infrastructure. Now, you've deployed your application, but there would be bugs tomorrow. Is there a way that we can maybe troubleshoot it very quickly or maybe look at metrics, have alerts, just like a normal traditional environment, but you have to be quicker when it comes to blockchain. Now, if there is a bug, with the help of Anthos, all of the logs and metrics, wherever they are deployed, shift to a central control plane. Now, you're able to traverse through your logs or look at your monitoring or even define service level indicators or service level objectives for your nodes or your applications. Now, but these are a lot of things that it can do. But the best part here is that as Web3 tries to solve the openness, all of Anthos that you see on the slide here, everything is based on an open source technology, therefore conforming to the need of being open. Now, once you have a reliable and a scalable infrastructure, developers can now focus on innovation. But how do we even think about security here? Now, with Software Delivery Shield, Google Cloud is able to help you in this. Now, the first and foremost thing, let me start with the cloud workstations. Now, say if I'm a new developer being onboarded in an organization, I need an environment to code. What Cloud Workstations does is helps you to able to create this environment, scale it up and provision it as and when you need, with all of the configurations already built in that the developer will require for them to code. Now, as soon as a new person comes in, you just provision it and give to the developer. Now, no more the security people or your backend infra team need to worry about that. I need to ensure that this developer is using what's organization-wide allotted for, whether the configurations are consistent. They don't need to worry about that anymore. Next is when they start coding. Now, Cloud Code will help them to able to create and deploy and build or unit test their applications within their laptops or within these workstations with real-time security feedback. Now, why is this important? The reason behind today when we code, we deploy it for our dev and ISIT environments, and then we realize that there is an error, and then we ask the developers to fix it again. This increases the loop. Now, the entire idea is because we want innovation to be faster and apps to be released faster, we want this loop to be reduced. Cloud Code Protect will help you to give real-time feedback so that you can check if there is a problem while you're unit testing in your laptop. Now, while you're doing this code, you also have access to assured open source softwares, which are verified and tested by Google. Now, I've coded it, I've checked in into a source code repository. The moment I do that, Cloud Build, the serverless CI platform, the pipeline gets triggered, which will check out your code, build it, and create a container to store it in an artifact registry. As soon as I store it in the artifact registry, it triggers a container analysis. Now, this container analysis will scan your container from bottom up. It will scan all your OS layers to tell you if there is a vulnerability somewhere. Now, once I've done that, now this container needs to go and deploy into a Kubernetes engine or our serverless place, Cloud Run. Now, Google Cloud Deploy helps us to deploy that as well as promote from dev UAT to prod. But how do you assure that these containers, what they're getting deployed, are verified by the organization? Now, binary authorization helps us to do that. Now, as we are deploying these containers, we sign these containers with the organization's key. Now, as part of the pipeline, we will verify whether these keys is the one that the organization has been signed. In case if they are not trusted, in case of the verification fails, the image does not get deployed. Now the infra is ready, the application is deployed. Now the nodes need to talk to each other, or the application need to be accessible across the globe. Now Google Cloud provides us with a premium tier network which is globally accessed. We have 33 regions, 100 zones, and which is completely 100% carbon free since 2007. We also have 16 subsea cables which are shock free. One of the major differentiators when it comes to, and the reason we say it's premium tier, is because of our edge pops. We have 146 edge pops across the globe. Now, what do we mean by that? Now, this is where we connect Google's network to the internet via peering. Now, why do you say that's relevant? Even more in the blockchain world, because this enables to keep the traffic on Google's private network rather than on the internet. Now, this helps us to ensure that we give you better reliability, better performance, and more security. Next comes data. Now, the amount of data has increased, so we need more real-time intelligence and stream analytics. I'm sure all of the data enthusiasts that there are have heard about BigQuery. But there's a particular problem in blockchain to solve for. In blockchain, you need to execute all kinds of query for which you need to index every single block from the genesis. Genesis is the first block. This means that you need to get access to a node, which can be either operating on your own or you're using a third-party provider. Then by using the API, you'll query and index all the historical data. Then you will listen for all of the new blocks that are coming in and the transactions that are being called for, like we looked at how blockchain works, as they're being finalized. And then, of course, you need a proper DevOps process to ensure that it's operational and healthy. It's too much of an hassle, right? Now, the good news is that all of this data is available as part of BigQuery today. Our BigQuery provides public datasets that supports 9 different chains, including Ethereum, Bitcoin, Polygon, Dogecoin, and a lot of others. We have worked with the open source community and our friends at Nansen to develop an open source ETL repository to index this data. And for the costing, you only pay for when you're using BigQuery. Apart from this, BigQuery is able to provide you real-time historical chain analysis. Now, every Web3 companies now do not need to parse blockchain data into data warehouse anymore. This reduces time to market. Now, data is sorted. What about visualization? Right? You need to keep in track of all of the insights that are happening. Now that's where Looker comes in. Coinbase, our partners have been using, or our customers have been using Looker embedded analytics for a few years now to power custom insights as part of their trading UI. Now, these insights, like the balance of trading activity at any point in time, help to provide end users, with better knowledge of what's going on in the market, and thereby ultimately encouraging more trading, and for Coinbase, more fees earned. So, network sorted, security got an idea of, dev experience got an idea of, data sorted, security we have to still come to. Now, infrastructure, one portion is where you're storing all of this data, right? You need to get quick read access across the large volumes of data that there are, right? Now, how do you do that? And the major one thing that we need is that as the application needs to scale, the infrastructure which GK is scaling, your backend where you're storing this data, that also needs to scale, right? And Spanner solves all of these problems. Now, Spanner is a globally consistent, fully managed database, providing you with traditional benefits of just another SQL database, with transactions, high availability, schema changes without any downtime. The best part is that it scales horizontally from 1 to thousands of servers. Cloud Spanner has relational semantics with schemas, enforced data types, strong consistency, and asset transactions across rows. And one of the good parts of Spanner is that you don't need to relearn a lot of things, because it's not a custom SQL query language. It's just standard SQL. It gives you 4 nines of SLA, or even 5 lines of SLA, depending upon how you choose to deploy it. Either it can be regional or it could be multi-regional configurations. Now, internally, we've battle tested Spanner with a lot of our customers, and it's like the default database for our developers internally itself. Okay. Now we've looked at the major things. We come to the most important section, and that is security. Google Cloud, by default, provides encryption by default, right? So when you're storing all of this data in the database, or even when you're using GKE or GCE, the data that is being in transit, or the data that is being stored, not just in the database, say it is being stored in my storage, my object storage, my persistent disk, which is block storage, or my file storage, they are all encrypted by default. But as I was explaining you how blockchain works, there are a couple of things that I mentioned. Use of private keys to sign, right, a digital signature. Now, a lot of employees which are being onboarded need to access all of these things also, right? So there are a lot of security aspects that you need to keep in mind. Now, the first and foremost is key management. Now, these keys that we are talking about needs to be stored somewhere. So you're able to manage these keys on GCP using KMS, or a customer managed key also is possible. With cloud identity, you can talk about the value of governing the different people who need to access the environment and ensuring by giving them the least privilege access. So say if I need to access GKE for deploying my container, I only get access to GKE, not to the rest of the product and suite that GCP has. And this really is important, especially in the global distributed workspace, right? You need to be able to give your employees the flexibility to work from anywhere, and cloud identity becomes very, very important. Next is DLP. Now, all of these systems are very, very critical. So you need to be up top or to understand or detect if there is a data loss. Cloud HSM is a cloud-hosted hardware security module for signing or executed transactions. And Cloud EKM helps us to even extend, like Anthos helps us to extend on-prem our GKE engines. Cloud EKM helps customers so that they can support several external key managers, which requires the key storage to be in a certain jurisdiction, say because of some governance, they need to be stored on-prem, or they need to follow some specific key standards, which therefore they can't store it on the cloud, right? Now, this is about the integrities that there are. But overall, there are so many hackers, right? Just in our traditional world, even in the Web3 world, it's open to so many attack vectors. With more and more anonymity that we're trying to bring in and no central ecosystem, security becomes very, very important. And you need to be up top it right at any point of time. Now, Badger DAO reveals that it was hacked for $120 million, and they hired cybersecurity firm Mandiant to do that. Mandiant is our recent acquisition from Google Cloud, which helps us to improve threat, incident, any organization to improve threat, incident, and exposure management. So you will know as soon as possible if there is a threat that comes in for that organization. So this is about GCP solving these challenges, but let's see how did we ensure that customers are using all of this. Right? Let's look at the experience with our customers and what they have to say. Now, Dapper Labs, I'm sure you've heard about the NPA Top Shot NFT. Now, the first blockchain application, they were able to reach 1 million users. And they did that by using GCE. They deployed a high-performance execution node on Google Cloud Platform. Chainstack, another customer of ours, deploys their enterprise smart contracts and app dev platform. It's running on GKE today and across multiple blockchain protocols. Hedera, the developer network focused on decentralized applications. It makes best use of the premium network tier that we provide. Theta Lab ingests from 60,000 to 200K transactions per day into BigQuery for all of the real-time analytics that I spoke about. Blockchain.com built Ethereum Blockchain Explorer with Cloud Spanner and saved 30% with costs. Block.one and other distributed ledger technology make use of the secure encrypted virtualization that there is. Now you see the slide talks about something called as confidential compute. Now all of our compute engines, whether just as a VM that you deploy or they are behind GKE, they have something called as confidential compute. Now what this means is that now not only you're encrypting the data that you're storing in a PD, on a block storage file store, on an object store, or in a database, but the in-memory data that you have in your RAM, confidential compute helps you to encrypt that as well. So it gives you another layer of security that there is. Now, these are not just all, but we are working with so many other blockchain customers and they're choosing GCP to build. To mention two more, Axie Infinity, they power their Axie blockchain validators and game engines on GCP virtual machines and Kubernetes engine. Nansen is a leader in the data analytics. They are able to scan more than 0.5 petabytes of data in a single day to serve customers world-class insights. Now, this has been only, I would say, 30% or 40% of what we're doing to help customers. These are something that GCP already had, which Web3 customers are leveraging to deploy their blockchain or smart contracts or dApps. Now, we understand that blockchain also needs a different way of working, right? And just to make sure that the developers are getting maximum needs, what we've recently announced is a blockchain node engine. Now, while self-managed nodes are often difficult to deploy or require constant management that I've spoken about, blockchain node engine is the fully managed node hosting service that can minimize the need for node operations. Now, Web3 companies who require dedicated nodes can relay transactions, they can deploy smart contracts, they can read or write blockchain data with the reliability, performance, and security that they expect. Ethereum will be the first blockchain supported by blockchain node engine, enabling developers to provision fully managed Ethereum nodes with secure blockchain access. Now, let's just delve deep into it. Now, manually, when you're deploying a node, it's a time-intensive process, right? What do you basically do? You involve provisioning a compute instance, then you install an Ethereum client and wait for the node to sync with the entire network. Now, imagine this network is huge, right? And the number of nodes that are participating in this network can be So many. So syncing a full node from the first block can take several days. Google Cloud's blockchain node engine is aiming to make this process faster and easier by allowing developers to deploy a new node with a single operation and specify the desired region and network. Now, this is just so many things that Google Cloud has been doing, and there are so many things that the larger parent company, Google or Alphabet, has been doing. That's all that I had today. If there are any questions, I would like to defer to that. Thank you.
So we have questions for Ashmitha from the audience. Ashmitha, the first question is, what are the measures taken in GCP Cloud to avoid information breach in Web3?
Right. To answer this question, actually, it's just not with Web3. Even in the Web2 world that we are in today, we have so many organizations deploying their applications. Information breach or data breach is the most important thing that we always have in our top of mind, right? There are various things that I have already mentioned. Google Cloud out of the box provides encryption, right? And these are keys which are managed by us. So nobody has access to keys, even the developers who are developing these products or us who are even talking about these products to other customers. Not even the storage, but the encryption is in transit, the data in transit as well. Apart from that, you have cloud, I spoke about cloud identity, KSM, you can utilize all of these to ensure that even if you are bringing your own key to encrypt the data, it's safely put in place. Then is about the traffic that is coming in into Google Cloud. You have Cloud Armor, which gives you out-of-the-box WAF capabilities so that you can ensure all of the geo-listing that you can do and the traditional WAF rules and policy that you can put in right there. You even have reCAPTCHA, which is out of the box available by us to help you ensure that these processes and transactions are happening in a secure way. So I would say whereas security becomes very key in Web3, but it's just not Web3. Any application, data breach is the most important part, and there are so various areas, whether they are on runtime, whether we are something we are deploying. There are best practices that we always work with our customers that they are ensuring that there is no breach that there is. Yeah, thank you.
Advertising is the core revenue generator for most social media platforms. How will Web3 impact those advertising and media?
I was expecting this question, right? Because this is like a very common question to ask that, okay, I spoke about Web2 and it was all about data monetizing of data, and Google does that. So we have ads, right? You have YouTube, you have ads. These were the ones, along with others that there are dominating the internet industry today. Well, I won't look at the question in this way that, okay, what now, right? But we look at it this way. Web 1, Google helped move with all of the innovations that was brought in with search and ads, we've been able to come here, and Google has always been a pioneer in the evolution, or always been there to be contributing into the entire evolution of the World Wide Web that there is. And Web3 is one another interesting area that we kind of we look at. Rather than looking at what will it do with our ads revenue, there are so many areas that we can leverage, from NFTs, with working with customers, with their DeFi, or all of that I spoke about, right? Being a hosted with a blockchain node engine, now we can host these blockchain nodes right out of the box, right? So these are various other areas that we are looking at, and we are mostly looking at being an innovator and contribute into the community rather than thinking about what will happen to Web2. All of our different products, Google Pay, YouTube, then there are other non-Google, right? As part of the alphabet, there are so many various ways that we have been trying to work with the community in different industries, right? All of the 10x visions, we're trying to have different new 10x ways to solve all of those problems. I spoke about insurance, I spoke about housing, helping agricultural industries use Web3 technology, right? So these are the areas that we're kind of trying to contribute more rather than looking at it, right? What about, of course, the Web3, Web2 section there.
Well, thank you, Ashmitha, for the wonderful session and for joining us today with our AI forum.
My pleasure. Thank you so much for having me here.